Hello YouTube, this is Umozo3. In the previous lesson, we took a look at something called the switch statement, and basically we said that the switch statement sort of provides an alternative for using an if-else block, right? And we can basically have the output of our code depend on whether particular expressions are true or false, and those expressions are called Booleans, and we've been developing an understanding of how Booleans work in Java and why we would want to use them and how they can make our code more interesting and more robust. So what we're going to do is open up a class called example, right? You can just make sure that you have a class open in Java, and it's going to have a main method just like all of our lessons have used since the beginning. And we can go ahead and review a few examples of what we were talking about in previous videos. So we could say Boolean A, B, C, and so this one goes ahead and declares 3 Booleans on the same line. And then we could say A equals 400 greater than 322. B equals 400 equal to 322, and C equals 8 less than cat.length. Okay, and so basically this is making a reference to one of the string methods that we talked about in the previous video, right? In lessons 5 and 6, what we did is we went into our browser and we went either to Google or Blackle, but we tried researching string Java API, and one of the methods that the string class provides is called length. So on a particular string, you can say string.length with parentheses, and that would return the number of characters that are in that string. And so this would be a false Boolean, and this would also be a false Boolean, but this first one would be true, right? And so we could go ahead and say something like system.out.println of A and B, or A and C. Okay, so hopefully that makes sense to you, but hopefully you can predict that this would be a false Boolean, right? Because A and B would be false, but A and C would also be false, right? So then if we go ahead and run it, we get false printed on the console. But anyway, the point of doing all of that was to go ahead and to understand these different expressions, right? So you could say Boolean D equals 5 greater than 6. So you can also go ahead and declare and initialize 2 Booleans on the same line, right? So what if you said tree.substring or tree.last index of E is less than 3. Okay, so hopefully you can figure out whether these Booleans would evaluate to true or false, right? Presumably both of these would evaluate to false because the last occurrence of E within tree shows up at index position 3. And then you could say something like if D, you could say something like system.out.println of sup. All right. Otherwise, if E, you could say system.out.println of dog, right? And then you could say otherwise, you could say system.out.println of tree. Okay, and so hopefully this makes sense to you. This is a pretty clear program, right? But then we can go ahead and run the main method and we would get the tree here because D, it went ahead and checked to see if D was true, but D is false. So then it goes ahead and checks to see if E is true, but then E is false. So then it goes ahead and runs else, because we said that else is alternative code that runs if none of the Booleans preceding it were true, right? What if you go ahead and say D equals 5 less than 6? So then we would run sup, right? Because then the first Boolean is true, and that's why sup gets printed on the console. So hopefully that's clear to you. What if just E was true, right? So what if we say 5 greater than 6, but tree.last index of E is less than or equal to 3? So now that's a true Boolean. So now we can go ahead and run it and we get dog. Okay, so what if both D and D were true? So then you just run sup, because we said that with an if else block, exactly one of the blocks will run, right? So once D becomes true, we don't even need to evaluate E. It doesn't even matter whether or not E is true because we ran the code for the D Boolean. And then we also talked about this switch statement. So we're going to say int W equals 100, and then we could say switch of W over 10, right? We could say something like that. And then we could say case 8, system.out.println of August. Okay, I'll just make it lowercase. And you could say case 9, system.out.println of September. Case 10, system.out.println of October. Case 11, system.out.println of November. And then default, system.out.println of December. Okay, and then we can also, so we can think about what's going to happen here. So essentially, the way that a switch statement works, we said, is that once one of these case values is the true value, so it tries to evaluate W over 10. Well, is W over 10 equal to 8? Is the integer division, are there 8 full groups of 10 in the number 100? No, so we would skip that case. Well, what about 9? Is 100 divided by 10 equal to 9? No, so we skip and we do not print September. Is 100 divided by 10 equal to 10? Yes, so we're going to print October, okay? But the point is that the reason that an if-else block is a little different from a switched case block is because with a switched case block, we're going to evaluate all subsequent cases, okay? So we would also evaluate November, okay? We would also evaluate December, and that's what you have to understand about this switched case architecture. So we get October, November, December. So it's going to evaluate all subsequent cases, right? What if we go ahead and install a break statement here? Okay, so now what if we go ahead and install a break statement at 11? So now we can go ahead and run it. And now we just get up to October and November because it evaluated these two cases, right? Because the case was 10, that was the true case. And then all the subsequent cases run until we encounter a break statement, or, you know, at the bottom once we've run default. But then we said the way to form an else if out of a break statement is just to make sure, or out of a switch statement, is to make sure that you have break statements at the end of every case, okay? And it doesn't actually matter whether or not you have a break statement at the end of the default. It might or might not be good etiquette to have one. But the point is that it doesn't make a difference. You could go ahead and compile it and then run void main string args, and then you just get October. And then as practice to yourself, you can go ahead and think about how you would formulate the equivalent if else block, right? You would have to say if W over 10 is equals 8, right? And then you could say system.out.println of August, right? But then you could go ahead and fill out the rest of this on your own. But then you could say otherwise, if W over 10 equals 9, you would say system.out.println of September, right? And you'd have about 5 cases to go ahead and complete, right? And so ... and then you would say otherwise at the bottom, and then you would say system.out.println of December, right? And so that would cover the 4 cases. And then if none of those 4 Booleans are true, if W over 10 is not 8, 9, 10, or 11, then it would just print December, because we said that the default case runs if none of the other cases run. So hopefully that's clear to you. And then the default case will also run if one of the cases is true, but you don't install the break statement, right? That's why we printed October, November, and December the first time that we ran the code. What we're going to do now is think about iteration. We're going to think about looping in code. So I'm not sure how familiar you guys are already with loops, but what we're going to do is we're going to understand that if you wanted to print something to the console 482 times, there's a way to do it without needing to write 482 lines of code. So presumably, hopefully, that's something that would be intuitive to you, right? Like hopefully that makes sense to you and you would be able to predict that there's a way to do that, right? But you don't need, but this is called looping or iteration, and basically allows you to execute a block of code, a similar or repeated block of code multiple times in an efficient way, right? Without needing to write tons and tons of code. And so we're going to learn about something called a while loop. Okay, and so with the way that a while loop works is the first thing that you're going to do, so there's going to be basically 3, or I guess 3.5, I guess 4 steps. We'll say 4 steps. Okay, so the first thing that you do is you need to initialize a counting variable. Okay, so you're going to say something like int x equals 0. Okay, and then you're going to have while and then a particular Boolean. So basically the way that a while loop works, so a while loop executes a repeated number of times. It executes the loop body every time the Boolean that the while loop is checking is true. Okay, and so basically the while is going to accept some Booleans. So for example, while x is less than 4. So we could say while x is less than 4. Okay, so the while in parentheses, so in parentheses is a Boolean that the while loop must check before it runs for the next time. Okay, and that's basically all that you need to know about it, is that we're going to execute the while loop code every time the Boolean that it checks is true. What if when we first check the Boolean's false. So what if we just make it to the while loop for the first time and it's false? Well, then we don't print any code, right? We're just going to skip over the loop. What if the Boolean is always true? So what if we say something like while true, or while 3 is less than 268,117? Well, then the loop would run forever, right? It would run infinitely. That's called an infinite loop. And that actually leads to a problem in computer programming. And it's something that we're going to need to be careful about. Okay, so I guess the third step would be write a line of code that you want to execute multiple times. And I guess it doesn't just have to be a line, but you could say write code that you want to execute multiple times. So you could say something like system.out.println of x, and this happens within the while loop. So it will be iterated over and over again, right? As many times as the Boolean is true, we're going to run the contents of the loop body. So hopefully that's clear to you. And then the last thing that you need to do is important. You need to increment the counting variable so that eventually the Boolean that the while loop is checking will become false. So this is how you prevent an infinite loop. So basically, if you say something while x is less than 4, and then inside your while loop you just say system.out.println of x. Well, that would basically just keep x at 0, and then it would say, well, is 0 less than 4? Yes, so print 0. Is 0 less than 4? Yes, so print 0. Is 0 less than 4? Yes, so print 0. And it would never get off of 0, and that would be an infinitely long running program, and that's probably not what you want. So what we're going to do is we're going to have a similar example. I'm just going to say int w equals 4, and then we're going to say, well, w is less than 10, so you don't even have to start it at 0. But we're going to say system.out.println of w, and then we're going to say w plus equals 1. So I guess the code here, the example, you could say x plus equals 1, or x plus plus, or x equals x plus 1, right? It's 3 different ways of doing the exact same thing, but the point is that we have our 4 steps here. So step 1 is initializing the counting variable. Okay, so you need to basically set a variable equal to something. You need to give it an initial value. So then while Boolean to check. Okay, and so this is sort of like step 2, I guess. And then here, this is step 3. So this is the essence. Okay, so this is the looped code that occurs repeatedly. Okay, so what is it? Why are you creating this loop? What is it that you want to print over and over again? And then finally, step 4, this will be increment of the counting variable for loop control. So this prevents an infinite loop, because otherwise W is never going to get off of 4. You're just going to print 4, 4, 4, 4, 4, 4, 4, 4, 4, right? But the goal is to print 4, 5, 6, 7, 8, 9, because it's going to print each of the values of W incrementing by 1 each time. So it's going to print 4, and then it's going to take W from 4 to 5. Is 5 less than 10? Yes, we're going to print 5, because now the value of W would be 5 after we already went through the loop one time. And then we're going to print 5 and increment W from 5 to 6. Well, is 6 less than 10? Yes, so now we're going to print W, but now W is 6. We're going to print 6 on the console, and then increment W from 6 to 7. Well, is 7 less than 10? Yes, we're going to go ahead and print 7, because the value of W is now 7. But the point is that you would get the numbers 4, 5, 6, 7, 8, 9. Like, what happens at the end? Is 9 less than 10? Yes, so we're going to print 9, because W is 9. But then we take W from 9 to 10, but 10 is not less than 10. And that's why you don't print 10 on the console, right? Because 10 is not less than 10. But what if you say W less than or equal to 10? Or what if you said W is less than 10 or W equals 10? That's another way of doing the same thing, right? It's less than or equal to 10. But the point is that you could go ahead and run main string args, and now you would get the 10 there. So hopefully that's clear to you. What if we go ahead and go up by 2 every time? So we're just going to go ahead and make the increment more than 2. So I guess a note is that you can increment by more than 1. You can also decrement and go in a decreasing direction. Okay, and so we're going to see different examples of that, but now we're just going to go ahead and compile it. But the adjustment that we made here is now, instead of incrementing the values of W, 4, 5, 6, 7, 8, 9, 10, we're just going to go 4, 6, 8, 10. We're just going to get even numbers, because the step each time is going to be 2. So now you just get 4, 6, 8, and 10. Then what if we said, int s equals 300, and then we're going to mix this up a little bit. So now we're going to go down. We're going to say, well, s is greater than 64, system.out.println of s, and then we're going to say s minus equals 100. So this is an example of a decreasing example. But the point is that usually by convention, we say that the counting variable is going to start at like 0 or some small number and work its way up to a cap. But not 100% of the time, okay? You don't have to do things that way. So this would just print 300, 200, 100, right? Because is 100 greater than 64? Yes, so we're going to print 100 on the console, but then the new value of s is going to be 0. That's the last value that s becomes, but 0 is not bigger than 64, right? And you could just go ahead and make sure that the final value of s after the loop runs is 0, right? Because we decreased s 3 times, but that's why we're printing 0 at the end, is because we asked to print the value of s at the end, but 0 would not be printed within the context of the while loop because 0 is not bigger than 64. So hopefully that's clear to you. What if you didn't have an increment or a decrement? So like we said, this would create an infinite loop, right? And so if you just said, well, s is greater than 64, system.out.println of s, well, that would just give you a boatload of 300s. And I guess I'll just demonstrate that for fun. But this is not a practical program, right? You just get 300s over and over again, and it's not what you want to have happen. And that's why this step 4 is so critical, right? Like this step 4 is at least as important as everything else, right? And so you just want to make sure that you have some kind of increment, right? It doesn't even have to be a fast increment. You can just go down by 1 every time. But the point is that you would eventually want your loop to terminate, right? And so that would print what, 236 numbers, right? 237, I guess. But you just get all of them, right? And it's pretty clean. And it's just, we didn't have to write 237 lines of code to print all of those numbers, right? And they just descend pretty reliably. So hopefully that's clear to you. Let's do another example with strings. So we're going to say string w equals watermelon. Okay, and then we're going to say basically int s equals 0. And then we're going to say while s is less than w dot length. So this is another example, but here we're calling on one of the instance methods that we studied from the string class in lessons 5 and 6, right? And then we're going to say system.out.println of, we're going to say w.substring of s plus 1, but let's go ahead and make it uppercase. So we have to get a little more practice with string methods, but we're going to understand what's going on with this example. So we're gonna start a variable s at 0, right? And we have a string w called watermelon. We're gonna say, well, s is less than the length of that string, which is 10. Like 0 is certainly less than 10. So you're gonna print w.substring of s plus 1 dot to uppercase, right? So the dot substring method. Remember, if you take a string and you call dot substring on it and you pass in 2 arguments, it returns another string with all the characters in your starting string of your original string starting at index position s and ending just before index position s plus 1. So it would just give you basically the character at index position s, but uppercase. Okay, so the lowercase w at the beginning will become a capital W. Okay, the lowercase a will become a capital A. And since we're calling system.out.println, it would just print the capital letters on different lines, right? So W, A, T, E, R, but on different lines and capital it, right? And so that's why we have to say S++, is because we need to iterate. We need to make it through the entire string. So we're not going to get off of that first W in watermelon if we do not increment S within the context of the loop. So now we're just going to go ahead and run it. And then we get watermelon. So we get the letters of watermelon uppercase printed one at a time, right? And then what if we also said s plus equals 3? So then we would just get every third character, right? So that would be like W and then E and then E, right? So we, and then I guess N, right? So it'll give you the characters at index positions 0, 3, 6, and 9. So it'd be like lean, right? On different lines. Okay, so hopefully that's clear to you. And you can go ahead and try your own examples of this, right? What if you only wanted the first 5 letters, right? What if you just wanted water, right? And so then you could just go ahead and increment by 1, but you could have different Booleans here, and you should play around with making adjustments in your code and seeing what effect different operations have. So that would just give us water. But the point is that as long as you study and memorize and practice these 4 components, you initialize a counting variable, You check a particular Boolean, you execute a piece of code multiple times, and then you increment the variable so that the Boolean that the while loop is checking is eventually false, so that your loop will eventually terminate because you don't want to have an infinite loop. So hopefully that was interesting for you. From UMOS03, thanks for watching, and please subscribe.